Welcome students. In the previous lecture, we have studied some steps in the manufacture of ethanol from the molasses by fermentation process, and we have kept the process for fermentation, and due to this process ethanol is formed, and this ethanol must be separated. The next point is separation of alcohol. The wash obtained after filtration contains 8 to 10% ethanol. Also it contains aldehyde, fuel oil as another constituents. For the separation of alcohol from other constituents, wash is subjected to the fractional distillation, because this must be done in fractional distillation only. Simple distillation is not suitable for the separation, and this is done using special fractionating columns called as steel columns, or it is known as beer steel column. Fractionating column consists of many cells. Yes, we will show in the diagram. This is a unit, here this is a tall, these are the columns. Okay, this is one. Okay, yes, here these are the fractionated column. Yes, here they contain many cells. This is 1, 2, 3, 4, 5. Okay, and therefore these are known as baffle plates, and these are the copper tubing for the passing of constituents. Okay. What is the procedure? Wash is pumped into coil where it is preheated, that is of course from the pipes, and it enters in the column from the top end. That is, the matter is taken into the column from the top, while the steam is passed from the bottom. As the matter comes down, the steam goes up, heat exchange takes place, and as a result, as the matter contains more volatile component, less volatile component, as more volatile components are having less boiling point, they are vaporized quickly. These more volatile components are aldehydes and alcohols. They are removed by vaporizing from the wash, and these vapors move up in the column, and in this column there are at the top aldehyde column is there, because aldehydes are more volatile than alcohols, and therefore aldehydes are allowed to escape from the column and aldehydes are removed. Okay. Here. Alcohol, being comparatively less volatile than aldehyde, it ascends the column little slowly, it rises the column little. The vapors are removed from the side outlet of the column at the top to condense. It is sent to the condenser, and it is converted into liquid and called as rectified spirit. The temperature of the alcohol at which it condenses is 78.3 degree. The uncondensed alcohol vapors leave the rectifier at its top end and are condensed with the help of condenser, and thus the alcohol formed is completely condensed, and therefore it is of the 95% strength. Another constituent of that mash is a fuel oil. It is a comparatively high boiling, that is less volatile, and it vaporizes very slowly, and these vapors cannot ascend, and therefore they fall to us in the column, and therefore they remain at the lower shell, and they are removed from the lower shell of the column. Now the liquid, the final liquid contains at the bottom contains about 10% solid matter, and it is also called as a spent wash. The rectifier spirit which is taken, I will show the diagram. Yes, here. This is the rectifying column here. Okay. Hot wash is taken, and thus here from the the hot wash goes, the steam comes from the bottom, hot wash goes, heat exchange takes place, the lower boiling impurities are removed. These are the lower boiling steam and alcohol vapor, they are removed here. And again it is taken in the rectifier. Here rectification, that is repeatedly boiling and evaporation takes place, and thus the low boiling impurities, aldehydes, are removed to the aldehyde column, alcohol being comparatively less volatile than aldehyde. It is removed from the side tube, it is taken for the condensation. This is a condenser, and it is converted into rectified spirit, that is in the liquid form. Okay, the wash. And fusel oil is collected from the side tube. The last spent wash is collected here. This is the process. Yes, we have seen. Yes, it is seen. Now, rectified spirit is an azeotropic mixture of 95.6% of ethanol and 4.4% of water, and it is obtained from rectification, therefore it is known as a rectified spirit. Ethyl alcohol forms a constant boiling mixture, that is known as azeotropic mixture. It contains by weight 95.87% of alcohol. Okay. Of course, the water from the rectifier spirit cannot be removed absolutely in this method, and therefore this azeotropic mixture is collected as a rectified spirit. It is used in the alcoholic beverages, it is converted into toxic, that is a denatured spirit, and it is also used to prepare absolute alcohol. This is the denatured spirit because it is used in the laboratory, and it is denatured by mixing a toxic material in the ethyl alcohol, because by keeping in mind the ill effects of alcohol beverages, this process is done. Okay, and therefore to prevent the illegal consumption of industrial alcohol for drinking purpose, the rectifier spirit is not supplied to the industry. Denatured spirit, that is made poisonous. After that it is supplied to the industry for their use. Okay. The production of absolute alcohol, that is totally free from water alcohol, 10% alcohol, that is 10% pure alcohol is called as absolute alcohol, and it is totally free. This rectifier spirit obtained from molasses, yes, we have seen it contains 95% alcohol and 5% of water. This is done in the laboratory by using special methods. Okay. Now, these are the laboratory methods. Okay. The power alcohol we are going to see. The alcohol used for generating power is called as a power alcohol, and that is used for running the vehicles, and therefore power alcohol consists of 80% of alcohol, that is absolute alcohol, that is without water, and 20% of petrol, and it is used as a fuel for automobiles and also as antifreeze for radiators, that is motor radiators. because radiators, when it is a water is running from the radiator, the water can convert into ice on the fans of the radiators and the fan can stop. And for anti-freezing, this is used. Okay, it is also used as a gasol. It's economical than pure gasoline petrol. That is, power alcohol is economical from that petrol. Now, what are the disadvantages of fermentation industry? Of course, the process is very slow. It requires much time. The product obtained is impure and it need to have further treatment. And of course, for this production, the investment is high cost. That is, it requires much money and more energy. The last point of the topic is the byproducts of alcohol industry and their uses. Now, this manufacture of ethanol from molasses gives the byproducts. Number one is carbon dioxide. The larger quantity of carbon dioxide gas is evolved during fermentation, which is in the pure form. It is liquefied and solidified. The solid carbon dioxide gas is known as a dry ice, which is used as a refrigerant, that is cooling purpose. Then second byproduct, acetaldehyde, which is collected at the top in the aldehyde column and which is obtained in the volatile matter. It is used for the preparation of chemicals like acetic acid, paraldehyde, then rubber accelerators, phenolic resins, and also in the preparation of dyes, drugs, and insecticides. The third byproduct is the spent wash. It is the liquid left behind after distillation of alcohol from the wash. It contains the nutritive ingredients of the starting material, that is protein, fats, and therefore can be used as a cattle feed. Then last byproduct is the fusel oil. It is a bright yellow oil with unpleasant smell. It is collected at the bottom. It contains a mixture of higher alcohols like normal propyl, normal butyl, isoamyl, and active amyl alcohols. All these alcohols are produced from the protein matter present in the molasses. And these alcohols can be separated by fractional distillation. Out of these, normal propyl and normal butyl alcohols are used for the preparation of artificial essence and scents. Okay. With this, we have completed our topic. Thank you.